Okay guys, so now let's solve this problem. A train can travel 50% faster than a car. Both starts from a point A at the same time and reach point B 70 kilometers away from point A at the same time, right? So a single point, and from that single point both of the train as well as car are moving at the same direction, but the train is 50% faster than the car. Now this is very very important. Once it is suggesting that 50% faster, so if we don't know the speed of any of it, right? We don't know it. We simply know that train lost about 15.5 minutes while stopping at stations, the speed of the car, right? So it's completely relative to each other, but we don't know the speed of any one of it. So let's assume the speed, right? So we need to assume something. Let the speed of the car, let's say here, let the speed of the car be x kilometer per hour. For example, let's say it's x kilometer per hour. Now we assume the speed of the car because that's what we need to find, right? So if we assume the speed of the car is x, then obviously the speed of the train is 50% faster than the car, right? So the speed of the train here will be 50% faster. Now what do you mean by 50% faster? 50% faster means if we are talking about, so 50%, so 50 divided by 100, that percent faster, right? So if the speed of the car is 100 kilometer per hour, and the speed of the train will be 100 plus 50 there, so 150 divided by 100 hour. So here in this case the speed of the train will be 150 by 100 into the speed of the car, that is x, right? So these are rough, we don't require it. So that should be the speed of the train, because 50% faster means the actual speed plus the 50 kilometers more multiplied by the actual speed that we're getting, that is the speed of the car, which is x here. So we get both the speeds obviously related to each other. So if this is the situation, then what they are telling us, so let's say the time taken, they're telling that both of them start their journey from point A at the same time and reach the point B 75 kilometers away from point A at the same time. So just travel and move and reach from point A to B at the same time. So the time they taken to reach from A to B are same, right? So what is going to be that? So the time taken for the car to reach, so the time here for the car, so let me write time for the car here, obviously equals to, time equals to the normal formula of the distance divided by the speed. That's the formula of time. So here the distance is 75 kilometers and the speed here is also we know x kilometers. So this is going to be the time taken for car to reach at point B. Similarly, the time taken for, so let's say the time taken for the train to reach point B, again same, distance divided by speed, and this is going to be 150. So you can simply write it as c by 2. So simply let me write it as cx by 2 divided by the speed. The speed here is, sorry, that's the speed. So let's say the distance traveled is 70 and the speed is 3x by 2 that we get from here. So it is going to be 75 multiplied by 2 divided by 3x. So this is the speed, this is the time taken by this train to travel, right? So these are the situation. So in this condition, these are the times and these things are equal. And what it is telling, on the way, however, the train lost about 12.5 minutes, right? So what we need to do is simply know that this time taken, 75 by x, this is the time taken by the car to reach, and the same time should be taken by the train, but train lost 12.5 minutes, right? So what we need to conclude, we need to conclude this 3x equals and plus the time taken 12.5 minutes. Now you know this value is in the minutes, right? This value is in the minutes. Now you remember that we need to convert all these things in hour, because every calculation is going on in kilometer per hour, right? So kmph is required, and we need to convert this minute into hour. So to convert a minute into hour, what's the formula? The formula is simply divide it with 60. So simply we can write it 75 into 2 by 3x plus 12.5 divided by 60, right? And simply we can take out this point from here, multiply it at the bottom with 10. So here will be 125 divided by 16 to 10. And in this side we know same thing, 75 by x. So we get our value, right? Once we get our value, let's take every x related part in this direction. So it should be 150 divided by 3x equals to 125 by 600 here. So 3x, so 3 into 75, and the answer is going to be 22, yeah, minus 150 divided by 125 by 600. Simple equation solve here. Here 3x, and this should be 75 more, so 75 equals to 125 by 600. And here you can write 3x multiplied 125 600 into 75, and kind of complicated though. 600 into 75 divided by 125, and here we can put x equals to final 600 into 75 125 into 3. So here it would be this 240. 120 is the value of x now. So once we get the value of x is 120, that is the kmph or kilometer per hour. So let's find the options. Yes, 120 kmph is there, and that is option C. So here option C is the correct answer. So the take home message here, obviously it's very easy, but you need to read it very carefully, because what it is telling you, both of them start their journey from point A, reach the point B at the same time. That's the critical point, because in this case you simply can put these things, the time taken by the car equals to the time taken by the train. But remember, train lost 12.5 minutes. That's why we need to add this minute here, and that's the most crucial part of this problem. We need to add this lost time here. If you don't add this lost time with this time taken by the train, otherwise this problem will be wrong, right? So if you add this and simply solve this equation, you can get the answer pretty easily. So that's it guys, and I hope that's helpful. Thank you.